Hi everyone. Well, this is the lab number 8, randomization distribution. And what it is about? The randomization distribution is a method of determining how often the observed difference between treatment groups would occur due to random chance. Um, well, I won't read this all of this, but essentially, when we have two populations, and our concern is the means of the populations or proportions, all right, like it says here, proportions and means. We want to test whether, by taking samples, whether the difference is if there is a significant difference, right, between the two populations by using samples. So to know, this has to do with hypothesis testing. So please see my videos or the notes in the book for hypothesis testing. So we're going to be using here some rules about that. All right. Study design. This experiment was conducted to evaluate the effectiveness of animal facilitated therapy with dolphins, controlling for the influence of the natural setting in the treatment of mild to moderate depression. The study was carried out in Honduras and recruitment took place in the United States and Honduras. The participants were recruited through announcements on the internet, radio, newspapers, and hospitals. Of the 30 patients randomly assigned to the two groups of treatment, 2 dropped out the treatment group after the first week, and 3 withdrew their consent in the control group after they had been randomly allocated. The study was single blind, which used the intent to treat approach towards analyzing the data. All 30 subjects who were recruited for the experiment will be included in the analysis, whether or not they dropped out. All right, so let's do this activity. Lab data file Dolphin. A Minitab file that contains the data set has been provided. If you are having trouble, all of this is about how to open this, but I have explained how to do it before. So go to Minitab, file, open. Of course, the file is on Blackboard. Worksheet, local file, because I have it here on my computer. Dolphin, open. And there you have. That is the file. Now, data variable description, right? So notice here in the Minitab part, so far we have only 2 columns, therapy and improvement. The improvement is a variable, it's a categorical variable that has only 2 options, no and yes. Was there improvement? Yes or no, that's all. And for the therapy, we have the dolphin and the control. So we want to test whether we have a difference between these two, between the dolphin with dolphins method and the control. So first we have to do is data variables here. Go back here, data variables description, therapy, control dolphin, improvement, yes or no, coded improvement, no equal to 0, yes equal to 1. All right. First, notice in Minitab, the file doesn't have this column, coded improvement, so we have to include it. So I'm going to name here this one coded improvement. Continue without autosave, and then now we go to how to do that. Well, we're going to use a function that is the function if. We're going to calculator, and then I already have it here. You have to shoot the let me erase this so you can see it. you have to use the function if, this one, if, and then select the function, and now you can erase this. Now you have to put from the column improvement, if improvement is equal to, use quotation marks, no, then that's going to be equal to 0. If not, it's going to be equal to 1, because we have only two options, right? If it is not, it's yes. So if it is not, if it is no, it's going to be labeled by 1. And that's all. With this should work, and then OK. And notice, in the column number 3, now we have the column coded improvement, and for every no, we have 0. And for every yes, we have 1. That is the purpose of this. Now, once you have this, continue with the activity. Descriptive statistics, on the drop-down menu, select Stat Basic. And we will have to compute the mean in this case. So display, choose the column coded improvement. It's the only numerical column we have. By variables, therapy, statistics, we need only the mean. That okay? The mean, well, I put here the total, and then okay, and then okay. Variables, coded improvement, by variables, therapy, and that's okay. And there you have. Notice why the mean? Because since we have only zeros and 1, when you add the values and divide it by the total number of values within the variable therapy for control and dolphin, we are computing only the proportion, right? So that's why we have here, for control, the proportion of yes is 0.2 or 20%, and for dolphins, the proportions for yes is 0.67 or 67%. So it seems like the dolphin method, right, provides an improvement. It's better than only the control group. So let's continue with this, because here in the activity, because the improvements are coded as 1, the mean of the group is the same as the proportion of improved subjects. Initial results, proportion improved for dolphin is 67%. For control group is 20%. Difference, dolphin minus control is going to be 47%. That okay? Questions. Select the correct word or phrase from the choices in the parentheses. The proportion of subjects with an improvement in depressive symptoms was greater or less in the dolphin group than in the control group. Was greater in the dolphin group. Greater in the dolphin group. If this difference can be explained by random chance, then we would say that the findings are not or are statistically significant, that there is or there is not treatment effect. If the difference, in this case, if the difference can be explained by random chance, it is not due only to the method. In this case, the method is is the dolphins. Then the findings are not statistically significant. So you have to choose this, and it's not. All right. Now, what are we going to do next? Next, we're going to use randomization distribution. We're going to use a method that is resampling process. we're going to make an hypothesis test, all right, to test whether what happens if we take samples from this data, but the number of samples is going to be 1,000. And then based on those resamples, we're going to make an hypothesis test. It's going to be done automatically by Minitab, so I'm going to indicate only how to do it and how to draw the conclusions or draw or obtain the results. So again, on the drop down menu, select calc resampling, randomization test for 2 sample means, this one. And then you have to choose here samples coded improvement, the column we created, sample IDs, therapy, number of samples. First, you have to do it with 1,000. And then you click OK. If you did it correctly, you're going to obtain this graph. And then it says repeat the process with 3,000 samples. All right, you will have to do it with 3,000 samples. Okay, I'm going to explain how to respond to the questions with 1,000, but you do it with 3,000. Questions. What proportions of the resamples were as extreme or more extreme than the observed difference between the dolphin and control proportions improved? All right, first notice the difference is already stated here. Notice is here, this one is indicated by the lines in red. Could be either negative 0.467 or 0.467. So the difference between the values we obtained before here, and notice I did it here. In the first questions I responded I rounded up to 47%, but here in Minitab they did it 0.467. So that is the difference. Why we have one positive, one negative? Well, because here we consider the two cases. When we subtract one minus the other one, and then the other one minus the first one. I mean, the dolphin minus the control group, and then the control group minus the dolphin. That's why we have the same number but with different sign. That's all. So here, what proportions, go back to the activity, what proportions of the resamples were as extreme? Here only, you have to look only here, Minitab, at the graph. Is going to be this one, 0.012, proportion below negative 0.467. Well, first this one, negative 0.467 is this one, this number here, 0.010. 0.010, I mean, it's given there. And for the other one, 0.012. What is the p-value based on this simulation? All right, in the results you obtained, scroll down and you're going to find the p-value. The p-value is this one here. You see it? P-value 0.022. So for in this case was 0.022. Is this a statistically significant finding? Oh, to test that, we need to have a level of alpha. So use alpha equal to 0.05. So remember, we reject the null hypothesis, or we say that we have a statistical difference if the p-value is less than 0.05. So 0.022, it is less than 0.05, so yes. I'm going to choose the option yes. Is there evidence for a treatment effect? Yes. I mean, the difference we observed between the two methods, the dolphin methods and the control group, is not the only to chance. It is because this gives evidence to say that the dolphin methods works better. Yes. And I'm going to put here because p-value that is equal to 0.022 is less than alpha equal to 0.05. So you have to use alpha equal to 0.05, okay? There you have. Conclusion, the observed difference in proportion of improvement between the dolphin and control groups is unusual. It is likely or not likely to be due to random chance. It is not likely. Therefore, the data suggests that animal facilitated therapy with dolphins is an effective treatment for mild to moderate depression. All right, so you will have to do the same here. The same I responded, but now you will have to do it with 3,000. That okay? So you will have to complete this part by yourself. You will have to respond the same questions, but now do it with 3,000. All right, that's all by now. See you in the next video.